I'm Martin Rowe, Senior Technical Editor at EE World, and this is Ian Wong from Viavi Solutions. We are at the NYU 2023 Brooklyn 6G Summit, and we are actually right now in the NYU Tandon School of Engineering. And we're going to talk about networks. So, Ian, I heard you give a talk at a conference a few weeks ago, and the topic was generally Open RAN.
Correct.
And so can you give us an idea of what's the status of Open RAN? We've been hearing about this for several years. Where are we now?
Yeah, I would say we are at the maturing phase, right? So with any technology, there's kind of this hype cycle, right? So I think we're getting to a point now with Open RAN wherein it's no longer a question of whether it will happen. It's actually more of when. There are clearly some leaders in terms of tier one operators that are already, doing trial networks with it. We have operators like Dish or more Greenfield that has deployed it nationwide, and Rakuten, one of the earlier ones to do it. So I think Open RAN is happening. It is, are we there yet? No, right? But we're getting to a point wherein there's a lot of excitement still there, confidence that it will happen. Yeah.
There's been a lot of talk about 5G as a whole, and the business press are saying, well, it's not so great, but they're looking at it purely from a consumer
Correct.
perspective. But yet there's still quite a bit that has happened since 5G was originally introduced and is still going on in terms of 3GPP releases. And can you give us an idea of where we are now? I believe release 17 is done.
17 is done.
And 18 is getting
18
close.
is pretty much, we're getting there. Basically, the December plenary will kind of wrap it up. And there's already, there was a release 19 workshop in Taiwan, which I was at, and there's a lot of discussion about, what to do for release 19. And there's let's call it budding consensus more or less on what the priorities are. As you said, we're kind of turning into kind of a more pragmatic phase for 5G Advanced, right? Like our operators are saying, let's not, do a further enhanced of certain features when, the market traction is still not there. Let's focus on things that really matter, like coverage, capacity, private networks, making that work, and 5G femtocell is something that's gotten a lot of support kind of to work on for release 19. So we're kind of at that, as it's not the best times for the telecoms industry, right? So we're kind of turning into that, let's do the pragmatic thing. There is some preparation for 6G. The pretty much the only thing that got broad consensus was let's start the channel modeling aspects for 6G in the release 19 timeframe. So
I remember not quite at this point 10 years ago, maybe 8 years ago, we were starting to hear about channel modeling.
Correct.
And I remember hearing and seeing some equipment that a number of companies were doing at that time. Some of them were actually robots.
Yep.
That were going up the street and doing measurements. I want to get back to you later about something on release 19, but before we do that, one of the things that Open RAN has to deal with is interoperability.
Correct.
And I know that there have been some plug fests and there have been some other things. Where's the status of interoperability in terms of the plug fests, in terms of how is that coming along?
Right, and as you know, I am actually the co-chair of the test group within ORAN Alliance. So we organize a lot of the plug fests and the open test integration centers, or OTICs, right? So We've been doing PlugFest since 2019.
Right.
We've transitioned from one a year to 2 times a year starting in 2022. So one in spring, one in fall. And we're seeing a lot of participation from a lot of different companies. So it's not slowing down in that sense. Again, interoperability is definitely a key, important aspect, right, of Open RAN, because we're standardizing these interfaces, right, and you need to make sure equipment on both sides work. But there's also a lot of interfaces in ORAN, right? So the open front haul, which is between the RU and the DU, that's actually the most mature. We're actually seeing the PlugFest now almost like transitioning away from the open front haul because it's gotten to a point where it's fairly mature. Equipment that claim support, that align on parameters generally work with each other, right? As long as they're implementing, the same version of the spec. So, that's a long ways from, let's call it the 4G CPRI days, I would say. So it's definitely a big improvement. There's also a lot more efforts now around the other interfaces that ORAN is standardizing, right? Like the E2, which is more on the near real-time, RIC or RAN intelligent controller that is meant to, in a way, control, the DUs and CUs in the network, right? To do more intelligent things, utilize data, AI, and ML to make smarter decisions about, optimizing the network for energy efficiency, for, load balancing, et cetera. So we're seeing more of the intelligence aspects now being kind of, worked on by the alliance.
So we're sort of moving past the stage of can we get a solid link. Now it's a matter of really being able to do the real communication. So I'll call it a higher layer, higher level communication than just making sure can we establish a link and keep it running.
Absolutely, right? I mean, because really ORAN is not just about the open interfaces, right? It's actually a key tenet of ORAN has always been network intelligence, right? Utilizing data, utilizing softwareized network to make smarter decisions, right? Making it more autonomous, et cetera. So we're seeing a lot of momentum behind that right now. Even a lot of academics doing research in that area. So there's definitely a lot of excitement in that area. And also, of course, transitioning from just plain interoperability to, focusing on performance and scale, right? Because it's not enough for an RU and DU to talk to each other, right? It needs to be able to match, if not exceed, the performance of single vendor, incumbent RAN, right? So there's a lot of focus on how do we scale up performance, load and stress of these interfaces, et cetera.
Okay, well, you work for a company that's in the test equipment business.
Sure.
And what kind of testing is going on? I mean, how do you know that that these interfaces are working as intended? What are the metrics? What are the tests that you have to do?
Right. No, that's a good question. I mean, I would say, it starts from the specifications, right, which is created by the ORAN Alliance, both the technical specs and the test specifications. So it's actually fairly well specified what test needs to be run for, let's say, an interface implementation to be compliant. So that's just basic functional conformance testing, right? That's let's go ground zero, right? And then you move on to interoperability testing, which we talked about, which is does equipment A and B talk to each other? Now A and C, do they still talk to each other, right? So that's interop testing. That's also specified in the specs. And finally, there's performance testing, both at the, let's call it interface level, but also at the end-to-end level, right? And in fact, that's really what operators at the end of the day care about, right?
Right.
Does my full end-to-end network work and perform? And so there's a lot of performance-based test specifications as well in the, we call them end-to-end test specifications, which is published also by the ORAN Alliance. So I think those are, and then once you move beyond that, then you start doing field testing, and then you put on the intelligence layer, then it's kind of more elaborate field testing. And obviously, what we all want is to see it deployed in large scale.
So when once you get to the field testing, and that's more or less, let's see if it really works. Let's see if we if you know that's really trial. But just before you get to that, and maybe even at some of that field trial, you're still going to have some test equipment involved.
For sure, yes.
And what is the test equipment doing? Is it capturing packets and analyzing? What goes on here?
Right. I mean, on the basic level, yes. Right. For basic functional and interoperability testing, it's about where the packets put together correctly, are they communicating with each other, right? But then when you move on to more end-to-end testing, then for example, in Viavi, we have actually the leading UE emulator in the market, right? So we actually via the RF interface to, let's say, a base station that's, in this case, whether it's ORAN or traditional RAN, doesn't matter. You always need the RF interface all the way to the interface towards the core network, right? So we wrap that base station around sometimes with a real core or a core emulator, and then we emulate the UEs as seen by the base station. So base station thinks that it's actually connected to 1,000 or even 10,000 user equipment.
I see.
But we're just really emulating that. And then it allows us to really load up the base station to see kind of where it breaks, right? And then really, we call it load and stress testing, which is kind of the true performance at scale. Yeah.
When you're emulating this user equipment, and there are two things that come to mind. One, obviously, is cell phones.
Yes.
The other is, I'll call it everything else.
Yes.
And the everything else is going to be, in my mind, is different.
Correct.
In that cell phones, you probably want to test it by sending video, something very data intensive. But with IoT devices, you're generally looking at much, much lower data rates, much less data, but to really stress the network, you need to simulate a lot more of them.
Correct.
So how does that work? How many IoT devices versus cell phones would someone be testing or simulating with test equipment?
That's a great question. So we, in addition to just, as you said, like emulating the devices themselves, what's most important is really the traffic characteristics for those devices, right? As you said, we actually have stateful emulation of, let's emulate maybe 1,000, handsets that are doing YouTube or web browsing or voice call, whatever, right? Maybe voice over NR, et cetera. So that's something that we could do. We've also just recently released RedCap, right? RedCap is essentially the 5G NR version of more lower capacity IoT type devices.
Sure.
So there, then the traffic profile, of course, is vastly different. As you said, lower data rate, more bursty, and then in that case, we can go up to close to 10,000 devices, right?
Okay.
And again, but at the end of the day, one single base station, even the most capable macro, can only get to a certain point, right? And so in a lot of our testing, we can actually test multiple carriers, right? You can think of a multi-cell, base station, communicating to up to 10,000 devices, and it's basically something that the biggest network vendors out there would be doing, both as part of their verification, but even as part of their regression testing.
Now, in simulating user devices. Now, for example, here we're in Brooklyn right now. I can imagine a base station having to handle 10,000 handsets, certainly around, anywhere here, anywhere in New York, pretty much anywhere in New York City or any other large city. Does the testing, even though it seems like you would need more devices if you're testing IoT, do you envision that in the range of a cell of having what would have to be many more than 10,000 IoT devices in such a small area? I mean, is that realistic?
Yeah, no, that's a good question. I mean, at the end of the day, there is the difference of, let's call it the idle users, right? Which means they're just camped on the network, but not really active. But also, which ones are really truly active, right? And clearly, for more idle devices, we can support a lot more. There's also a difference between, as you know, in 5G and R, we have a kind of a hierarchical type of architecture. Right? There's multiple RUs can connect to a DU, multiple DUs can connect back to a CU. So what we've done is we've actually, at the RF level, you typically can load up to a certain amount to maybe one DU, right? But then how do I emulate even more RUs into that DU? And in that case, we can actually emulate it via the eCPRI interface, via fiber. Now we skip the RF, and now we can load up a lot more devices, right?
Okay.
And finally, we go even further up into a CU, which is now going to control potentially up to hundreds or even thousands of DUs in a macro network. At that point, the fidelity of the simulation goes lower, but then we can truly crank up the UEs to even 10,000 and 100,000 to really see where the CU breaks. So I see it as we progress into the network, the fidelity of simulation goes lower, but then the capacity goes higher. And we've seen, we've tested, something that we released recently with Samsung up to 1 terabits per second of their CU that we've tried to load, to really show, and at that point you're already testing more in the cloud, obviously through a fiber interface.
There's a lot. I often follow the optical side of things, and even the electrical connections to the optical side. I've been following that for a long time, and they're talking about. I think it may be more for data centers because they're talking about 224 gigabits per second and so on, and I think those are mostly for data centers, at least now. In 10 years from now, maybe not, because they'll be up to much higher speeds. But the speeds that are needed, between an RU and a DU, between a DU and a CU, what kind of technology are we talking about here?
I think for the most part, we're talking about, I would say, QSFP type of connectors, and 25 gigs per connector type of, per line, right? You can have 4 lines, so 100 gig type Ethernet is definitely possible. Into a DU, and you can have multiple QSFPs, right? And then you scale that further as you go up, right? As you go into a CU, it becomes, and at that point, you're seeing CUs in the data centers themselves, right? Because they're basically part of the edge cloud or even the regional cloud, et cetera. So, we're that's the technology that I'm seeing a lot of.
Okay. One last question. I mentioned earlier that I wanted to come back to release 19. And 2 weeks ago, we were at another 6G conference, or I know I was. I'm not sure. I don't recall if you were there, but okay. Well, anyway, there was another one 2 weeks ago, and something came up there, and that I was not familiar with. And let me see if I can get this right. I believe it was called Integrated Communication and Sensing.
Yes.
Or sometimes called Joint Communication and Sensing. Are you familiar with that?
Yes.
Can you tell me what that potentially is and how it might become part of Release 19?
Yes, there's definitely quite a bit of excitement around that use case, right? At the end of the day, it's, how do I utilize the network as a sensor? Right? And think of it as, operators, of course, trying to find creative ways to monetize their network, right? And here's a brand new use case wherein, hey, this can be for law enforcement, for safety critical applications, or even for more retail type or more local. I think there's a lot of excitement in that area. I guess JCAS and ICAS and I mentioned the channel modeling work. In fact, that's really where a lot of the focus is. What's interesting is if you add sensing on top of communications, right? You may need additional KPIs, right? Not just your standard RF propagation model primarily for communications, right? You may need kind of smaller features, because especially if you go to higher frequencies, and so the metrics of the channel characterization might be a bit different. And I think it's under research right now, and of course there's also talk about waveforms, right? What waveforms can we design so that it's actually good for both communication and sensing, or should we use two different type of waveforms but use the same hardware? And I think there's still a lot of debate on what the right approach is, but I definitely sense a general excitement from several operators on saying, hey, there could be something to this use case. To definitely at the end of the day, is they're thinking about how do I monetize my network.
When you said higher frequencies, are we talking millimeter wave or sub-terahertz or both?
I would say definitely millimeter wave as a starting point. There is also a lot of research, as you know, to do sub-terahertz or terahertz, which, to allow you to have much more, the higher the frequency, the more precise your sensing can be. And so yeah, I would say that's still wide open. I must say in the Release 19 workshop, there is a general sense from some operators to say that, hey, why don't we focus on, let's make millimeter wave work better before we even go higher. There's also a lot of excitement on the mid-band, right? Upper mid-band between 7 and 24 as a nice sweet spot, right? It's between the C-band today and the millimeter wave bands in 5G. There's obviously, a lot of incumbent, especially satellite usage there. So some things to work out from a regulatory standpoint. But generally, there is excitement in, the potential of that upper mid-band to do much larger MIMO, right, to really increase the capacity, and or do some sensing, right, definitely a lot better than the 3.5 gig for that purpose. So
because I've heard of that 3.5 roughly in that, I'll call it the mid-band frequencies being used for position sensing. I've even heard of people doing that with Wi-Fi.
yeah.
So the excitement here comes because this would be something the carriers would be able to do, as opposed to individuals or businesses trying to do something. I've seen some things where if you just to be able to identify if a person is in a particular room.
Correct.
That work's been going on for
Kind of
for a
like
number
gesture
of years.
recognition, or
Yes.
definitely for public safety, applications, they definitely come in handy. Recognizing threats, and of course utilizing a lot of AI as well, right, to kind of do that. But yeah, absolutely. I think that's, and in a way, if you think about it, location is just another type of sensing, right? Knowing where things are, and now we're trying to add more value to that, right? And what else can we do apart from just where things are, and even for location. In fact, you may not know this, but Viavi is one of the leading providers of geolocation for operators today, for tier 1 operators. And people think, oh, there's GPS. Why do I need to worry about that? I mean, most countries, it's for privacy reasons, or a lot of UEs are indoors, right? So you really, for most operators, that they don't even know where their subscribers are, for the most part. So yeah, utilizing a lot more of the metrics, utilizing data analytics to know, to use that to pinpoint location, is already something that's of course there in 5G and even in 4G. But yeah, I think going beyond that is where some operators are definitely excited.
Okay, Ian Wong from Viavi, thank you very much. For EE World, I'm Martin Rowe. Thank you for watching.